Carbon fiber gets the headlines. Aluminum owns the factories. But there's a material that's been building airplanes longer than both combined, and it's still winning on specific strength, damping, and repairability. Wood, not nostalgia, not compromise. Engineering that you can shape with hand tools, inspect with your eyes, and repair in your own garage. Today you'll discover why the best builders never abandoned it. Wooden aircraft, the best material to build and fly. When doubters claim wood belongs in museums, one French design proves them spectacularly wrong with engineering that rivals modern composites. The MJ-5 Sirocco is a masterclass in wooden semi-monocoque construction. Its fuselage uses birch aircraft plywood skins, typically 1/8 to 3/16 inch thick, bonded to spruce frames and stringers so the skin carries shear like a true torsion shell. The wing is a closed torsion box with spruce cap strips forming box spar flanges, 1/8 inch birch plywood shear webs, and a closed leading edge that locks torsional stiffness for clean aileron response. Control hinge brackets, gear, firewall, and carry-through fittings are 4130 steel with AN hardware. Adhesives are epoxy or resorcinol with long-grain scarf joints at 12:1 or 15:1 ratios, ensuring load transfer without hard spots. Proper bonding demands clamp pressure spread with cawls and cure temperature within specification. With Lycoming O320 or O360 engines delivering 140 to 180 horsepower, the Sirocco comfortably cruises around 140 to 155 miles per hour with approaches at 60 to 65 miles per hour. If damage occurs, repairs are reproducible at home by scarfing out to sound wood, replacing webs or cap segments, rebalancing the control, and returning to flight without expensive factory parts. That combination of specific stiffness, damping, reparability, and cost control is why an all-wood semi-monocoque still surprises pilots raised on aluminum skins and carbon brochures. The engineering proves that proper wooden construction delivers performance metrics that make composite marketing departments nervous, while keeping maintenance firmly in the hands of skilled builders who understand the material's honest behavior under load and environmental factors. French designers understood that efficiency starts with simplicity, and one legendary model proves a two-car garage can birth serious aircraft. The D.11 distills wooden efficiency into something buildable and maintainable without industrial tooling or aerospace budgets. The fuselage is a spruce truss with birch ply skins where panels stabilize the bays, using plywood gussets and long grain scarfs to spread load paths cleanly. The signature wing uses the broken dihedral configuration. An anhedral center panel with dihedral outboard gives strong roll stability without heavy tip devices and continuous 1/8 inch ply shear webs with a closed leading edge forming a torsion box. Controls hinge on 4130 brackets while firewall and gear attach points are steel to avoid localized crushing. Typical engines range from Continental A65 to O200, delivering 65 to 100 horsepower. Expect 95 to 115 miles per hour cruise, approaches at 55 to 60 miles per hour, and practical grass field work in about 1,000 to 1,500 feet, thanks to low wing loading. Wood longevity is about water management through sealing every cut edge, including lightning holes, inspection doors and cable exits, maintaining varnish and UV top coats, and providing drain and vent holes in rib bays so humidity cannot wick into end grain. No specialized rivet guns, no alidine lines, no autoclave equipment required, just careful woodworking and adherence to CURE specifications. That is why massive social proof exists with countless flying examples, thousands of aggregate hours, and a community that can talk you through a spar cap scarf or a leading edge closeout on a Saturday afternoon. The global fleet demonstrates that properly executed wooden construction is not a nostalgic choice, but a repeatable engineering system that rewards attention to detail with decades of reliable service and straightforward owner-maintained operations that keep flying costs remarkably low compared to certificated metal alternatives. When yacht builders and aircraft engineers collaborate, the result redefines what wooden construction can achieve in speed and refinement. The Falco F.8L is the benchmark for wooden precision, an all-wood semi-monocoque shell executed to yacht-grade standards that prove craftsmanship can rival factory tolerances. The fuselage is not a stick and gusset box, but a molded birch aircraft plywood skin, typically laminated from 1/16 to 3/32 inch plies, bonded over spruce frames and stringers with carefully controlled pressure and temperature, creating a torsion cylinder with exceptional specific stiffness and low drag that carries most of the in-plane shear loads. A closed leading edge completes the torsion box, while tight tolerance, 4130 steel hinge brackets serve flaps and ailerons. Adhesives are aeronautical epoxies or resorcinol formaldehyde with long-grain scarf joints at 12:1 or 15:1 ratios mandatory, clamped with cawls so pressure is uniform across the bond line. With a Lycoming O320 or O360 delivering 150 to 180 horsepower, expect 170 to 190 miles per hour cruise, with honest IFR panel potential. Wood's structural damping trims, acoustic harshness and vibration transmitted to avionics, slowing fastener fretting compared with thin aluminum skins while controls feel machined. Keep the UV system healthy with primer and varnish under top coat, renew edge sealing at inspection doors and lightning holes, and verify drain and vent holes in closed bays. If a bruise or delamination appears, the fix is measured by scarfing to sound wood, bonding a matched ply layup, fairing and resealing without autoclave, rivet gun, or heat treat lines. The reward is a wooden airframe that cruises like a metal speedster with repairability. You can execute in a garage. The strongest argument that wood is not nostalgia, but precision engineering. In a material you can actually shape with hand tools and patient craftsmanship that delivers superior results. Budget-conscious pilots often assume performance requires factory checkbooks, but one design shatters that myth with garage-built accessibility. At the opposite end of the spectrum, the RagWing Special proves that minimum structure plus good technique equals practical flying on a paycheck budget without sacrificing safety margins. The fuselage is classic stick and gusset construction with straight spruce longerons and uprights often 3/4 to 1 inch square, joined with birch ply gussets 1/16 to 1/8 inch, thick, bonded in double shear. Strategic diagonals keep the panels from racking, while the wing uses straight spruce spars with thin ply shear webs and a fabric-covered D-section leading edge to add torsional dignity without weight penalty. The covering is polyester using Dacron or Seconite, shrunk with heat at 250 to 350 degrees Fahrenheit, and sealed with polybrush, polyspray, and UV top coat, turning fabric into a stressed skin that shares load and resists flutter. Power is modest with Aero VW or small 2 strokes common, so the design leans on low wing loading for performance, including stall at 30 to 35 miles per hour, short 600 to 1,000 feet grass operations when light, and docile approaches in the mid-40s miles per hour. That low speed window lets you operate from real-world fields and keeps kinetic energy down when something goes wrong during landing or taxiing operations. Hardware is standard AN, while firewall and gear fittings are usually 4-130 to avoid localized crushing. The outcome is the purest case for wood. Lowest dollars per flight hour, parts you can make yourself, and an airplane that trades raw speed for accessibility. When the choice is fly often versus dream long, wooden simplicity gets you airborne sooner and keeps you there with repairs you can do on a Saturday, using basic hand tools and readily available materials from any quality lumberyard that stocks aircraft-grade, spruce, and birch plywood, suitable for primary structural applications in amateur-built category aircraft. Modern technology meets traditional materials in ways that eliminate guesswork and accelerate build times dramatically. Computer precision transforms classic wooden construction into a predictable, low-stress experience. The Dakota Hawk shows how modern tooling turns wood into reliable results. The fuselage is spruce stick and gusset, but the gussets come CNC cut birch aircraft. Plywood with pre-located holes, so your joints land exactly where the designer intended. Straight spruce, longerons and uprights, often 3/4 to 1 inch, form rectangular bays, while diagonal braces prevent racking, and CNC gussets bond both faces. In double shear for structural efficiency, the wing is a proper torsion structure. Spruce cap strips top and bottom, continuous 1/8 inch birch ply shear webs, and a closed leading edge. The closed D-section leading edge is the magic because once skinned torsional deflection drops, ailerons stay authoritative and flutter margins grow substantially. Covering is polyester fabric using Seconite or Dacron heat, shrunk around 250 to 350 degrees Fahrenheit. Sealed with polybrush, polyspray plus UV top coat. With a Rotax 912 delivering 80 to 100 horsepower or a light O200 at 100 horsepower, expect 90 to 110 miles per hour cruise and approaches 50 to 60 miles per hour. CNC repeatability also helps maintenance because every rib bay and lightning hole matches the drawings, so inspections are fast. Wood health is water management. Seal every cut edge, add weep holes at bay low points, and provide vent paths so temperature cycles do not pump moisture in. If you ever discover a bruise, the repair is local and bench friendly. Scarf out to sound wood at 12 to 1, bond a new web segment, or replace a damaged cap without rivet guns, alidane, or heat treat. The result is a forgiving learning curve, predictable weight and balance, and a home built that flies honestly without requiring industrial tools or specialized aerospace fabrication equipment. Cross-country capability does not require metal construction or composite expense when French engineering scales up proven wooden efficiency. Think wooden Cessna 120 or 140. Mission wrapped in approachable construction methods. The D.150 Mascaret scales up DNA for comfortable cross-country without the complexity or cost of metal kits. The fuselage is semi-monocoque birch plywood over spruce frames and stringers, with skins, commonly 1/8 inch, acting as true shear panels that stabilize bays and transmit load around the cabin and baggage area, with proper scarf joints at 12 to 15 to 1 and continuous bond lines that stop stress concentrations, while edge sealing at windows blocks capillary wicking. The wing retains the signature broken dihedral for hands-off stability with spruce spars using continuous 1/8 inch ply shear webs, cap strips on ribs, and a closed leading edge creating a rigid torsion box. Many builders add drag and anti-drag diagonals for better tracking and turbulence, with a Continental O200 at 100 horsepower or Lycoming O235 delivering 115 to 120 horsepower. Expect 115 to 130 miles per hour cruise and approaches at 60 to 65 miles per hour. Short field manners owe to low wing loading, while real-world fuel burns keep weekend trips affordable, with wood's vibration damping, producing fewer buzz-induced cracks at steel fittings. Maintenance is procedural rather than exotic. Annuals check spar roots and carry through, gear attach clusters, firewall joints, and tail cone longerons, looking for imprinting at steel to wood interfaces and any glue line whitening. Keep the UV and paint system healthy using poly spray, urethane or varnish plus top coat, reseal edges after any avionics or wiring change, and confirm drain and vent holes in closed bays remain clear. Appeal to United States builders is simple. Comfortable cabin, honest numbers, parts you can fabricate on a bench, and repairs you control. The touring proof that wood is not nostalgia, but a repeatable engineering system that trades exotic tooling for craftsmanship you can master. French aerodynamic elegance meets structural intelligence in a design that proves wood can deliver both beauty and precision engineering. The Emeraude is wooden craftsmanship at its aerodynamic best. A smooth, low-drag, semi-monocoque shell, and a wing that proves a wood torsion box can feel machined and roll. The CP.301 uses birch aircraft plywood skins, commonly around 1/8 inch, bonded over spruce frames and stringers. Those skins are not cosmetic, but primary shear panels that close each bay and transmit loads around doors, windows, and baggage cutouts with every opening, getting edge sealing to block capillary, wicking into end grain and long grain scarf joints at 12 to 1 or 15 to 1 ratios, avoiding hard spots. Firewall and gear attach points rely on 40-130 steel brackets or hardwood crush blocks, with any steel to wood interface getting anti-corrosion treatment and sealed fastener bores. The wing is classic and stout, spruce spars with continuous 1/8 inch birch ply shear webs, spruce cap strips, and a closed leading edge that completes the torsion D section. With Continental O200 or light Lycoming, O235 delivering 85 to 120 horsepower, you will see around 105 to 125 miles per hour cruise, approaches around 55 to 60 miles per hour, and butter landings on grass thanks to low wing loading and wood's structural damping that filters runway chatter while ailerons stay crisp. After cover and paint using poly brush, poly spray plus urethane, or varnish plus top coat on exposed ply, maintain a healthy UV barrier and inspect weep holes and vents so closed bays can breathe. Annual focus includes spar roots and carry through, gear attach checking for imprinting, firewall joints, tail post, and longerons, and any paint cracks around glue lines as stress telltales. Damage control is bench friendly. For hanger rash, crease in the leading edge, scarf back to sound laminas, bond to matched ply layup following grain orientation, fair, prime, and top coat without rivet guns or heat treat ovens, proving elegant French design remains as practical as it is beautiful. Garage engineering reached its purest expression when one designer proved minimal tooling could produce maximum flying satisfaction. The poster child. For plans built, low tooling wooden airframes emerged from backyard workshops nationwide. The Flybaby features a fuselage that is a spruce truss with longerons and diagonals, often 3/4 to 1 inch section, joined with birch ply gussets and local ply skins around 1/8 to 1/4 inch, where panels need to act as shear webs. Critical nodes including firewall, gear, cabane, or strut, attach use 4130 steel fittings through sealed bores, backed up with hardwood crush blocks to spread point loads with every cut edge sealed before closeout, so end grain does not wick humidity. Wings are equally approachable. Spruce spars with cap strips around 1 1/4 to 1 1/2 inches deep depending on plan variant, 1/8 inch ply shear webs, spruce cap strips on simple ply ribs, and polyester fabric covering using Seconite or Dacron heat shrunk around 250 to 350 degrees Fahrenheit. Typical engines are Continental A65 to C85, delivering 65 to 85 horsepower. Expect around 90 to 100 miles per hour cruise, finals 50 to 55 miles per hour, and grass friendliness that makes 1,000-foot strips realistic when light, with build technique being the real safety system, through scarf joints at 12:1 minimum and grain selected for straightness. Before you close the wing, drill tiny weep holes at the low point of each rib bay and add a vent so pressure and temperature cycles do not pump moisture inside. After fabric, adopt a ritual. Fingertip fabric tension test, hinge line check for ovalization, look for whitening along glue lines indicating incipient bond stress, and examine spar feet and gear attach for imprinting or fretting at steel to wood interfaces. The magic is reproducibility. Scuff a leading edge and scarf, then patch and reseal, break a rib and trace the good one, building a clone on the bench, proving that carefully sealed spruce and ply structure delivers decades of honest flying. Depression-era ingenuity birthed an aircraft that still proves affordable. Flying needs nothing more than garage skills and determination. The original proof that garage-grade woodworking can yield safe, repeatable airplanes continues inspiring builders decades later. The Pietenpol Air Camper features a fuselage that is a spruce truss, straight longerons, often 3/4 to 1 inch square, or rectangular braced with diagonals and birch aircraft plywood gussets bonded in double shear. Local ply skins approximately 1/8 inch turn-slick bays into shear panels around cockpit and baggage with high load nodes including firewall, gear attach, cabane, or strut fittings, using 4130 steel plates bolted through sealed bores with hardwood crush blocks preventing localized compression. The wing is deliberately buildable on a living room table, spruce spars with continuous 1/8 inch ply shear webs, spruce cap strips, and simple plywood ribs spaced generously. Covering is polyester, using Dacron or Seconite heat, shrunk around 250 to 350 degrees Fahrenheit, and finished with polyfiber including polybrush, then polyspray UV, then top coat. Power plants are budget friendly, Aero VW or updated Model A, and automotive conversions in the 60 to 80 horsepower window are common. Expect around 80 to 95 miles per hour cruise and approaches in the high 40s to low 50s miles per hour with short grass operations, keeping the mission fun. Safety is in the method. Adhesive systems are aero epoxies or resorcinol. Use scarf joints at 12:1 or 15:1 ratios. Clamp with cawls to spread pressure roughly 30 to 60 pounds per square inch equivalent, and maintain shop conditions around 68 to 77 degrees Fahrenheit, with moderate humidity during cure. End grain is the sponge, so pre-seal every cut edge, including lightning holes, cable exits, inspection rings. Before closing a wing, drill tiny weep holes at the low point of each rib bay, and a discrete vent so temperature swings do not pump moisture inside. Repairs are the superpower. Crease a leading edge and scarf to sound ply, bond a matched patch with grain aligned, proving backyard ops can deliver decades of flying. Theater meets engineering when steel tube fuselages marry wooden wings in a configuration that stops crowds and simplifies maintenance simultaneously. The high drama. Way to show wood working with steel combines concentrated loads up front with graceful area aft. The Deuce uses a 4130 welded fuselage for engine mount, gear, cockpit cage, and cabane posts, isolating shock and providing hard attach points while everything aft stays light with tubes treated internally using LPS or bow shield type products and painted externally to prevent inside-out corrosion. Each wing panel is classic and robust. Spruce spars with 1/8 inch birch plywood shear webs, spruce cap strips, and a closed leading edge D section to build torsional stiffness, vital on a biplane where interplane loads and rigging tension can excite twist. The interplane architecture uses flying and landing wires in 4130 or stainless working pure tension, while cabanes carry the center section. Proper tensioning with a tensiometer and accurate incidence and stagger rigging give that on rails feel with hinge brackets in 4130, using bushings and control runs, staying accessible for inspection. Covering is polyester fabric, using Seconite or Dacron, shrunk around 250 to 350 degrees Fahrenheit, and finished with polybrush, polyspray UV plus top coat. Engines in the 100 to 150 horsepower bracket, including O200, O235, light O320, yield approaches around 55 to 60 miles per hour, and short field manners thanks to high total wing area. Maintenance blends two disciplines with woodside annual focus on spar roots, D-section skins, checking for hanger rash creases, rib cap glue lines, and edge sealing around inspection rings and cable exits while confirming weep holes are open. Steel side includes die check suspect weld clusters, inspect cabane attach points and gear sockets, and keep anti-corrosion coatings up to date. Rigging is its own ritual. Verify wire tensions, re-check incidents, sweep, and stagger after any fabric work or season change. Field repairs favor wood. Scarf out damaged leading edge ply, bond a patch, fare, and fly again, proving dramatic camera-ready aircraft with wooden wings stay both strong and serviceable with garage tools. The evidence speaks through decades of flying examples. Wood delivers specific strength, rivaling composites, and repairability that keeps owners in control. Which design surprised you most? Share your thoughts below. Hit that like button if this changed your view on aircraft materials. Subscribe and enable notifications for more technical deep dives. Share with aspiring builders because material choice matters. Watch the videos appearing on your screen and keep flying with us. Bye-bye.